everyone, this is Mrs. Snowbeck. Today we are going to talk about Unit 7, Lesson 4, and we're going to learn about inscribed angles. Now before we talk about inscribed angle, I want to remind you about what is a central angle. And remember, a central angle, if I take my highlighter here, I'll do it in blue, and I kind of go over this angle. You can see angle QCS. So angle QCS is what's known as a central angle, okay? And just remember, whatever that angle is, the arc is the same as that angle. Well, today we're going to talk about an inscribed angle. An inscribed angle is like this red one, okay? So an angle like angle QRS. So let's jot that down. Angle QRS, that's considered an inscribed angle, okay? Its vertex is right on the circle. Compared to the central angle, the vertex was at the center of the circle. So central angle, the corner of the angle is at the center, and an inscribed angle, the corner is on the circle. And then last but not least, when it talks about an intercepted arc, they're talking about the arc that the angle opens up to. So arc QS, with that little curve above it, would be considered an intercepted arc. It's like the part of the circle that the angle opens up to. Now here's some really important information. It says if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of the intercepted arc. So in other words, angle 1 is going to equal the measure of arc AB divided by 2. So let's just put a number out there. Let's say this arc is 100 degrees from A to B. Then this angle would be 50 degrees. It would be half as much if it's an inscribed angle. But if it was a central angle, like this one, then it would be 100 degrees. So it really depends where the corner of the angle is. If it's at the center, it's the same as the arc. If it's on the circle, then it's half of the arc. Let's try numbers 1 and 2. So find the measure of angle A. Think about what kind of angle angle A is. It's this angle right here. It's a central angle. So it should be the same as the arc. So if you're thinking this angle is 82, you are correct. But then it says find the measure of angle B. And angle B is down here, and that's going to be 82 divided by 2, which is 41. So that angle will only be 41 degrees. Okay, will you pause the video and try numbers 3 and 4? So angle A should be the same as the arc. So this is 165, so this is 165. Angle B, whoops, I'll write that down. Angle B is going to be half of it because angle B is on the circle. So it opens up to that 165, but it's an inscribed angle, so you have to divide by 2. And 165 divided by 2, let me type that in quick, is 82.5. So this one would have been 82.5. All right, let's try number 5. Find the measure of angle P. Angle P is right here. Here's angle P. And it opens up to this arc, the 70. So you have to think it's an inscribed angle, so what do we do to the 70? It should be half as much. So 70 divided by 2 is 35. 35 is your answer. Let's do the next one. Find the measure of arc PQ. Sometimes it helps if I erase my other previous work. So if I want to find the measure of arc PQ, that is this arc. Notice this angle opens up to that arc, and this angle is 56. Well, the angle is half of the arc. So how do you work backwards and find the arc? You would have to multiply by 2. So 56 times 2 will be 112 degrees. So this would be 112. Let's try number 7. Find the measure of angle C. So what I like to do is I like to think, where does angle C open up to? There it is. To me, it looks like it opens up to this 98 degrees, and we want to find that angle right there. So the angle should be half of the arc. So take 98, divide by 2. 49 is your answer. Okay. Let's try the next one. Number 8, find the measure of arc CF. Okay, so arc CF is this arc right here. Oh, look at this, you guys. This angle, that 40-degree angle, opens up to that arc. So if you take the 40 and you double it, you get 80. 80 is that arc. Please pause the video and try numbers 9 and 10 on your own. When you're done, unpause to check if you got them right. So if you need to pause the video and take a look at my work, go ahead. But here is what you should get for numbers 9 and 10. Now this one's really interesting. It says find the measure of angle F. So if I look at angle F, I can see it's an inscribed angle. It opens up to this arc over here. The problem is I don't know anything about that arc. So that's not super helpful. So then I have to think how can I find that angle? The trick is knowing something about angle G. So everybody look at angle G. Do you see how it opens up to, let me just show you this arc out here. Well, that arc is a semicircle, and a semicircle is 180 degrees. So if this is 180 degrees, then angle G must be 90 degrees. Must be half of 180. And think about this triangle that you see. I see a triangle. I'll outline it in yellow. That yellow triangle right there. I know something about the 3 corners of the triangle. They add up to 180 degrees. So I'm going to take angle F, angle H, angle G, add up all 3 of them, and say they have to equal 180. So 4x plus 2 plus 9x minus 3 plus 90 equal 180 degrees. Because again, the 3 corners in the triangle always add up to 180. Okay, so combine your like terms. 4x and 9x is 13x. And then we have 2, negative 3, and 90. And I think that is 89. And then equals 180. Subtract 89. And you get 13x equals 91. Divide by 13. And x equals 7. But we are not done. Think about the question. The question said, find the measure of angle F. So you're going to have to take this 7 and you're going to have to plug it in for angle F. So the measure of angle F equals 4 times 7 plus 2, which is 28 plus 2, which is 30. So the measure of angle F is 30 degrees. If 2 inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. All right, everybody draw an inscribed angle. See how the point is right on the circle? Now I'm going to have you draw a second inscribed angle, but it needs to open up to the same arc. So see how they both open up to that same arc, this arc over here? Well, what happens is, since they both open up to that same arc, then this angle here and this angle here, they are going to be congruent to each other. Number 12, notice angle T. Angle T opens up to arc SV. Here's arc SV up here. Well, angle U, I'll outline it in blue, angle U also opens up to that arc. That means angle T and angle U are the same size. This angle and this angle are the same size. So 3x minus 5 equals the 2x plus 15. These angles are congruent because they both open up to the same arc. All right, so do your algebra. Subtract 2x. You get x minus 5. These canceled, so equals 15. Add 5. X equals 20. Is that your final answer? No, it is not your final answer. You have to take that 20 and you have to plug it in. It wants the measure of angle T. So the measure of angle T is going to be 3 times 20 minus 5. Well, 3 times 20 is 60, and 60 minus 5 is 55. So that is your final answer. Will you guys pause the video and try number 13? When you're done, unpause the video. All right, so angle S and angle R both open up to the same arc. Here is angle S, and here is angle R. And so they must be equal to each other. And so 9x plus 2 equals 12x minus 13. Subtract 9x. Add 13. Divide by 3. If you got x equals 5, yay, you're right. But you're not done. So the next step is you're going to take that 5 and you're going to plug it in. They want you to find the measure of angle R. So you're going to have to plug it in right there. So let me move this up a little bit. The measure of angle R is going to be 12 times 5 minus 13. So 60 minus 13 should be 47. The measure of angle R is 47 degrees. Now it's your turn. Will you try Unit 7, Practice 4? If you need help, let me know. Have a great day.